Okay, here we are at the very end of chapter 17. So, we're going to look at some examples to be able to at least describe qualitatively what the pH at the end point would be for a particular titration. Would it be acidic, basic, or neutral when NaOH is added to it? So, let's take HCN. And HCN is a weak acid. And so a weak acid titrated with a strong base is going to be basic at the end point. And I'm going to take you back to one of the slides that I did before in the last video, which was this one here. And so here's an example of a weak acid with a strong base. And remember, I showed you that the center point of that vertical spike is above 7. It's not at 7 what you think of as the equivalence point because we call it neutral, but it's above 7 and it's due to the presence of the conjugate base. Okay, so if we go back, we can look at some of the other examples here. And we'll look at HNO3 with sodium hydroxide. HNO3 is a strong acid, sodium hydroxide is a strong base. That one's going to be neutral. That's that first titration curve that I showed you. And then I have a strong base with a weak acid again. And so whenever you have a strong base with a weak acid, you're going to be, the equivalence point will be around 8 because of the presence of the conjugate base that keeps the pH at the equivalence point a little bit higher. And so here I just put some quick little notes here. So you really need to know if the acid is strong or weak before you can make this broad assessment about acidic, basic, or neutral. And so then I said, what if these things are added, these reagents were added to HCl, which is a strong acid. Well, a strong acid with a strong base is going to be neutral. Now I have a strong acid with a weak base, and the strong acid with the weak base is going to have that end point a little bit lower than 7. I showed you an example of that where it was around 6. So that's because of, so it's going to register as an acidic pH at the end point due to the presence of the conjugate acid. So this is a little set of, cheat notes here for you. So if you titrate a strong acid and a strong base, at the end point you'll have neutralization. Strong acid with a weak base, at the end point your pH would read a little acidic. Weak acid with a strong base, a little basic. And a weak acid with a weak base would also be neutral. Okay, so one last thing that I want to do is I want to do a pH calculation at a particular point in the titration. So we're going to use a strong base. We're going to react that strong base with a weak acid. And so what I have is 40 milliliters of 0.1 molar NaOH, which gives me 0.004 moles of NaOH. And then I have 20 milliliters of 0.2 molar HClO, and that gives me 0.004 moles of that. So what I know is that when those two reagents react together, they're going to produce 0.004 moles because everything's in a 1-to-1 ratio. So I'll get the same number of moles of this conjugate base. So what I know then is that my conjugate base, a base will react with water to produce the hydroxide ion. So there's where your equilibrium reaction will come in and the equilibrium expression that we'll need to use. But the problem is I don't know the Kb. Since this is a weak base, I need to know the Kb value for it. So I do know from a previous lecture that Kw is equal to Ka times Kb. So if I know the Ka for the weak acid, which would be HClO, then I can find the Kb of that conjugate base, the ClO negative there, by plugging into this formula, Kw equals Ka times Kb. I solve for Kb. Now that I have my Kb, I set up my Kb expression. Kb is equal to the products over the reactant. I, of course, leave out the water. That's just what the ClO reacts with to produce hydroxide. Now I have this expression. Kb is equal to x times x over 0.004 over 0.06. This is where the liters make a difference now, because I had 0.004 of that ClO here, ClO negative. But I got that ClO by adding 40 milliliters of this and 20 milliliters of this. So that now means that this is in 60 milliliters altogether. So I have to take that mole value and divide by 0.06 liters. Then I do a little bit of math. I solve for my x. Once I get my x, I then do my POH is equal to the negative log of the hydroxide ion concentration. And then I go to my pH, 10.2. I calculate my pH using that other formula from a previous lecture. If you remember, pH plus POH equals 14. Okay, so here's a quick little sketch of what what it would look like here. And so what I have is near, this one's not going to have much of a spike because of the fact that I'm reacting with a weak acid. And so that's it. That's the end.